Welcome to this explainer. Now, I want you to imagine, just for a second, waking up one morning fully expecting the warm, familiar embrace of a spring sun. But instead, you step outside to find the sky completely choked with a relentless, unnatural haze. Days turn into weeks, weeks bleed into months, and that spring warmth, it just never arrives. Instead, you're watching snow fall in June. You're seeing crops wither and rot right in the fields. And soon, starvation starts creeping across entire continents. Now, I know that sounds like the plot of some dystopian sci-fi film, but it is a very real, very terrifying chapter of our own human history. Today, we're stepping back to the year 1815 to examine an event of such unbelievable, catastrophic power that it physically altered the atmosphere of our entire planet. We're talking about the eruption of Mount Tambora.
I had a dream, which was not all a dream. The bright sun was extinguished and the icy earth swung blind and blackening. Those words are actually penned by the poet Lord Byron in a piece he appropriately titled Darkness. Now, hearing lines like that, it's really easy to just assume they're purely the product of some gothic, melancholic imagination, right? But here's the chilling truth. This apocalyptic vision wasn't fiction at all. Byron was documenting reality. He was describing the actual, inescapable global climate of 1816, a literal darkness triggered by a massive volcano located in Indonesia, which was half a world away from where he sat shivering in Europe.
Okay, let's dive into this. To really understand the sheer scale of what happened, we have to look at the Volcanic Explosivity Index, or the VEI. This is a scale that rates eruptions from 0 all the way up to 8. The eruption of Mount Tambora in April of 1815 was a massive VEI 7 event. To put that into perspective for you, an eruption of this magnitude happens incredibly rarely. The next most recent VEI 7 before Tambora, that occurred all the way back in the year 1257. Tambora blew its top with such ferocious, unbelievable intensity that it ejected roughly 100 cubic kilometers of rock, ash, and pumice straight into the sky. The mountain itself, which once soared incredibly high into the clouds, completely collapsed into a caldera that was miles wide. So how exactly does a single geological event down in the Lesser Sunda Islands trigger a worldwide disaster? Well, the mechanics are actually fascinating, if also a bit terrifying. First, the volcano violently ejects this colossal ash cloud high up into the atmosphere. But it isn't just ash, we're talking about millions of tons of sulfur dioxide. As this sulfur reaches the stratosphere, it forms a dense veil of aerosols. Think of these microscopic particles as a giant planetary mirror. They literally reflect incoming solar radiation right back out into space, while at the exact same time trapping heat in the upper atmosphere. The result down at the surface level is immediate, and it is devastating. The ground is starved of sunlight, and global temperatures absolutely plummet. And this brilliantly illustrates the direct fallout of that atmospheric mirror. When we look at the seasonal temperature anomaly data for Central Europe around the time of that April 1815 eruption, it reveals a massive, undeniable plunge. We are talking about a severe global temperature drop of 0.4 to 0.7 degrees Celsius. Now, I know what you're thinking, that might sound like a tiny number, maybe just a rounding error on your weather app. But on a global scale, an average drop of almost a full degree Celsius is more than enough to throw the entire Earth's climate system into absolute chaos.
And that chaos manifested in what became grimly known as the year without a summer in 1816. Across New England and Europe, summer simply never showed up. Imagine living through a year where you had widespread frost in every single month. In parts of North America, locals dubbed it 1800 and froze to death, or the Summer of Mittens. The whole environment was just deeply, deeply confused. Trees stayed utterly leafless and brown. Small migratory birds, caught completely off guard by these freezing temperatures, literally dropped dead from the sky, their bodies just littering the fields. And above it all, the sun could barely pierce through this hazy, pale sky that carried a distinct, eerie, sulfurous tinge.
Of course, when the climate fails, human infrastructure is always the first casualty. Let's zoom in on the micro-level human toll here. Because that bitter cold just refused to break, the wheat simply rotted away in flooded fields. Between March and May of 1816, East Anglia over in the UK experienced a staggering 33% spike in the price of wheat. Suddenly, the cost of a basic loaf of bread vastly surpassed the daily wages of both agricultural and industrial laborers. People weren't just a little cold, they were completely desperate, destitute, and quite literally starving. And that desperation eventually boiled over right into the streets. Protesters assembled, arming themselves with whatever they could find, demanding a reduction in the price of food just so their families wouldn't perish.
They carried these flags bearing a terrifying ultimatum, and one woman reportedly shouted the rallying cry, "Bread or blood in Brandon this day." These starving agricultural laborers, realizing that mechanical innovation threatened the very few jobs they actually had left, began smashing up farming machinery. They weren't rioting out of malice, folks. They were rioting to survive. They demanded bread, and if society couldn't provide it, blood was going to be the cost.
The humanitarian crisis across mainland Europe was, well, it was arguably even worse. The constant, driving rain and the rotting harvests pushed ordinary, everyday people into unimaginable, soul-crushing despair. Thousands became climate refugees, just wandering aimlessly in rags. And the historical records we have from this time, they are deeply harrowing. Reports detailed how mothers, completely exhausted by hunger, by sorrow, and by the sheer inability to feed their wailing babies, actually confessed their temptation to simply end their suffering by drowning their own children in the Rhine River. It was an entire continent pushed to the absolute brink of sanity. But right in the midst of all this terrible darkness, there were these fleeting, incredible moments of human compassion. Take the Baroness de Krudner, for example. She was a wealthy evangelical figure who was suddenly confronted by a mile-long column of starving refugees right outside her window in Switzerland. And she didn't turn away. Instead, she set up a traveling soup kitchen. Spending roughly 120,000 francs of her own personal fortune, she fed a staggering 25,000 desperate climate refugees. During a time when local governments were utterly powerless and completely overwhelmed, her one-woman humanitarian crusade literally kept thousands of people from freezing or starving to death right there in the mud.
The birth of monsters, climate in art and literature. Let's move to and see how this builds, transitioning from that raw physical starvation into something much deeper.
See, the physical starvation and those endless rains of 1816 took a profound psychological toll, trapping artists and writers indoors for months. And it was against this exact gloomy backdrop, during a retreat near Lake Geneva, that Mary Shelley actually began writing Frankenstein. Now, we usually view the creature as a pure sci-fi invention, right? But literary historians now argue that Frankenstein is actually a masterpiece of disaster journalism. Shelley was witnessing these masses of wandering, starving, diseased climate victims pouring through the Swiss countryside. The creature, an outcast, suffering, full of rage, and entirely abandoned by his creator, serves as this incredibly powerful reflection of the dehumanized refugees she saw right outside her door. The monster, quite literally, was born from the trauma of the Tambora climate crisis.
Now you might be wondering, how do we confidently know the exact climate mechanics of a single year from over 2 centuries ago? Well, we have to shift from literature back to modern science, specifically a field called dendrochronology. This is the precise scientific method of dating and analyzing tree rings. Because trees respond so sensitively to their environment, their rings essentially serve as a highly accurate built-in historical ledger of global temperature and climate changes. A wide ring means a great growing season. A dense, narrow ring, that indicates cold and severe hardship.
Now, what's really interesting about this slide is how scientists use this exact data to settle a pretty major debate. Recently, some models actually suggested that following massive volcanic events like Tambora, trees in cold environments might have been so stunned that they failed to grow a ring at all, what they call the missing ring hypothesis. But scientists directly tested tree ring data, specifically looking at maximum latewood density against actual historical instrumental temperature records from Europe. And the result? The tree rings perfectly match the historical temperature drops. The 1816 ring isn't missing at all. It's right there, bearing the undeniable dense scar of a freezing summer, proving our chronological record of this incredible disaster is flawlessly accurate.
Modern climate insecurity. So, the crucial point is this. Bringing the reality of 1815 directly into our lap today, we have to recognize our own modern climate fragility.
Because the eruption of Mount Tambora is not just some fascinating piece of 19th century trivia, it is a blaring, unavoidable alarm bell for the present day. It shows us the terrifying interdependence of human and natural systems. Our modern, highly globalized world might seem insulated from all this, but we are just as deeply dependent on a stable climate as those struggling farmers were back in 1816. Which leaves us with a deeply unsettling question to really consider. The Earth is active. Another massive eruption, or honestly any sudden climatic shift that abruptly reduces sunlight, absolutely could happen again. If global agriculture were to suddenly collapse tomorrow, if the sun were dimmed and the harvest rotted in the fields all over the world simultaneously, how would we feed everyone? Do we actually have the resilience to survive our own year without a summer? It's a heavy question, but one definitely worth pondering.
And I hope this deep dive into Tambora has sparked your curiosity to learn a bit more about the delicate balance of the incredible world we inhabit. Thank you so much for joining me for this explainer.